Well folks, welcome back to the workshop. Today I've got a wee Alfra magnetic drill on for repair. Now this one is technically under warranty. Customer bought it here, stopped working, but he needs it fixed. Technically under warranty, so it should really go back to Alfra for a warranty repair. We can't do warranty repairs here for them. We're not an agent for them. We just fix them on the outside of warranty. This stopped working on him. He says the switch isn't actually working right. She's powering on, motor starting, but it won't keep going. So it's a faulty switch. Now, Alfra would have no problem covering this under a warranty, but we'd have to send this away to Alfra to get it repaired under a warranty. That's not going to work for the customer because he needs it now. Not today, but tomorrow at least. If it needs a switch, it's not going to be cheap because these here can cost about 50 or 60 euro. And that's if I have one on stock. Plus, it's also going to need a new lead. Looks like he had this sitting too close to what he was welding. It's burnt through the cable. But it's a good meter and a half in from the end of the lead. Might get away with cutting it off, otherwise have to replace the lead too. So I can't go out looking like that. So first up, we need to make sure it is actually the switch problem. So we have power going on anyway, just activating this switch. And the magnet's working. Yeah, it does the switch. So everything's working on the drill, the motor's working, the magnet's working, everything's right. It's just the wee electromagnet and this here switch has failed. There's a wee electromagnet built into the switch. Whenever you push it on and switch it on, the electromagnet gets energized and keeps it in the on position. It only disengages when you press the stop button or you lose power. Once that happens, power's cut the electromagnet and the switch is released. So when you switch these on, they should stay running. They stop like that, you need a new switch. Now these Alfra magnetic drills, this is the 35B, they're not the most expensive or high-tech magnetic drill in the world, but they are quite good quality. They're decent for what they are, plus they're actually made in Germany as well. They've got a good sized motor on them. What are they? 1100 watts. Decent motor, just a plain shaft, same as any. Two wee crub screws in the bottom, no quick release in these things, and just a magnet and the electro switch then for starting and stopping the motor, then just the angled rails then for the wage. Decent machine. They don't generally give a lot of bother. The main thing is cables and switches on them, the odd time a set of brushes. But obviously this one is going to need a switch. Four grub screws to get into this. So magnetic drills can be a little bit awkward to get into. Sometimes they're accesses to the side or to the front or from the back. This one's only from the front. Another problem there, loose connection. That wee spade pulled off as I opened it up. That's actually the power lead as well. Put a new spade on that. Power coming in, everything's wired onto earth to the body. Fairly simple setup. Power switches here, which takes your live and your neutral in. The power has simply been split after the switch. Half is going to this bridge rectifier right here, which is actually powering your magnet. So once you switch this on, the magnet comes on straight away. And then the other half then is running over here to your motor switch. It's a very simple setup, no big complicated control boards on this, just a bridge rectifier, 2 switches, simple on off switch and an electro on switch. That's it. And these layer wires are going off the bridge rectifier down onto your magnet. Simple and reliable, and generally cheap to keep going. So if you turn this on and it does nothing, if your lead's fine and this light's not coming on, it's this switch. If this light is coming on and your motor's running but you've got no magnet, it's your bridge rectifier. If your light's coming on and your magnet is working but your motor's not starting, it's your second switch over here with the electromagnet. Nice and simple. So this one is actually fairly standard. Actually, I think that is the same as the evolution switch. So I'll see if I have one of these in stock. Right, no joy. I actually don't have this switch. Thought I did, but I don't. Thought I had another type as well. It has a different setup on it. One where the actual electromagnet's not wired on through here. There's a second wee pin here. Thought I could modify this wiring to suit a different type of switch, but I don't even have that one. So I have to see what I can do with the switch itself. Maybe we can repair the switch itself. These things just push in. Just little wedges here that hold it on. Push them back. Slowly push your switch back out again. Now, inside of here, it's just a normal on-off switch. But up here, there should be an electromagnet, and that there basically has a metal pin from the on switch. Whenever you energize it, there's coils in the electromagnet. Energize, turn on the magnet, hold the pin on. What happens is one of the wee coils either breaks, or the connection for them breaks over here or wears out. So eventually the switch back here keeps working, but the electromagnet just doesn't keep it switched on. Sometimes you can actually fix them. I'll try and fix this one, see if I can get this man out of bother. This is actually inside of them. This is the insides of the switch, and this is the electromagnet part. So whenever you energize this, there's a copper coil inside of here. It gets energized, and the steel core in the middle then becomes a magnet. It holds on. The actual switch button then keeps it in the on position. Don't know which lever's which now. That is generally what you have to fix, and they're all basically the same. I have another one here that is faulty, but this one's actually wired differently. So instead of these two contacts connecting with these two wires over here, this one here, contact breaks away from this, goes to this side. Can modify these as well to fit these here types of switches. I don't know what to do here. Do I risk opening this one, trying to fix it, or to try to fix this one and modify it for this machine? Because if I mess this up, I'm going to have to order in a switch for it, which is going to take just as long as getting it fixed under warranty. But if I've messed around with the switch, they won't cover the warranty. I think I'm going to chance trying to fix this switch. Saves me having to mess around with any more wiring. It'll just be a straight swap over. So there's just the top and the bottom half. I held on with these wee clips. Pop them off. Top half of the switch comes off, and then this here is your switch itself. So the red button is this, the green button is a steel plate. So as you press this down, it lifts this bar in the middle and connects these two prongs together. So the live goes to the motor, the neutral goes to the motor. And this metal plate, whenever it goes down, activates the electromagnet. That becomes a magnet, sticks the plate down. So that won't release again until you either pull it away with the off switch or it loses power. But I have to see if I can fix it without messing up the actual switch side. First, see if we've got continuity on these coils. Right, nothing. So this should just come out. See here the wee copper winding. That's the beginning of the winding there. Clips onto this leg. And she's wrapped it around and around. As it comes back up to this side, clips onto this. So the only way you can actually fix them without uncoiling all the actual copper wire inside is if they've broken or they connect onto these legs, these wee contacts. This one, as you can see, still firmly attached. Right, we have resistance. So the coils might not be broken. If they're not broke, it could just be a case of us not getting contact. We might get away with just increasing the spring tension on the switch contacts. Just make sure they line up again now as they go on. These could have just weakened. Get one hook done, then the other. Push it down into place, and hopefully now those little probes are actually making proper contact. That might be all it is. If it's anything more, it's going to be a new switch. Now, only one way to test it, and that's to actually hook it back in and see if it runs. But obviously we should be still getting continuity between these two probes. See if that makes any difference. Also, just change this as well. This isn't a problem, but it's a weak connection, so it's going to become a problem. It's much better. Now, see if she makes any difference. You have power. We have magnets. Look at that. And we have an electromagnet switch. Sweet. That'll get this man up and running today. Now the only other thing is the cable. I think I'm just going to rewire the plug. There's no other damage on it. It's basically a new machine. So just shorten the cable. A little bit shorter, but it'll do fine. But it will need a new plug. So that's actually a molded 110 plug. Can't open it or rewire it. That's her, ready for work. That's just a wee handy one for you. If you have a magnetic drill or any machine that has a switch like this, these electro switches, if they stop working, you don't always have to replace them. Make sure the contacts are making correct contact. And check the wee wires get onto the end of the probes as well. Sometimes they can snap and just need to be reconnected. But they're very, very fine. A tiny piece of solder is all you need. That's her. Ready to go and ready for work. Anyway folks, thanks for watching. Hope you enjoyed that one. Hope somebody takes something from it. Hopefully somebody somewhere I'll save about 60 quid from having to buy a new switch for a machine like this. Thanks for watching, folks.